Thank you for testing yourselves by getting out of bed to come to a 9 a.m. talk on the last day, the morning after Unite at night. I have good news, your test is green, if perhaps a little unstable. We're going to talk today about testing and QA. So first, introduce ourselves.
Yep, I'm Warnecke. I am the developer on the Unity test framework.
And I'm Richard Fine. I'm a lead within Unity's internal tooling teams, and I just care a lot about tests. So what are we going to talk about today? Firstly, we're going to go through some of the new features in Unity's built-in test framework that Christian has added over the past few months. Then we're going to walk through a few kind of scenarios, like potential ways that you could use these new features in your productions. And lastly, we have a little demo applying some of these techniques into a realistic-ish game. So, Christian, over to you.
Thank you very much. So, first, a raise of hands. How many of you are involved in the quality assurance of your productions? Good, good. But quality is important. So, at Unity, one of the most important tools we have for quality assurance internally is the Unity test framework. We have developed this ourselves and are using it heavily. It is used to run automated tests, both in the editor and also on the devices we support. It comes built into Unity and is available to everybody. So, another raise of hands. How many of you have used the Unity test framework? It is also known as the TestRunner. Great. So, we would like the Unity test framework to be able to solve most of your testing needs. That is why we're working on making it as extensible as possible and as flexible as possible. So, the new thing is that we have gone further in our push towards more flexibility and customizability of the Unity test framework. We're doing this with the new API calls and possible callbacks and other points where you can hook into the code. But more about that later. Another big thing is that the Unity test framework is now a package.
Yes.
Yes,
Woo.
It's a good thing, because that means that we can ship stuff to you guys a lot faster, new bug fixes, new features, and it all goes a lot faster. It also means that you can have the source code of the Unity test framework locally. So you can look at the source code, you can step through it when debugging, but you can also modify it yourself if you want to. So, one of the new things is the TestRunner API. The core functionality of it is that you will be able to run your test programmatically from any script. It also allows you to retrieve a list of tests, either edit mode, play mode, or both, without running them. And then there's also some callbacks that you can hook into. Then you get a callback on different stages of the testing cycle. So these callbacks, they are when the test run starts and stops, but also when each individual level of the test starts and stops. So first on the whole test assembly, then on each individual test fixture, then down on each test class and on each test. Then the next test gets a start and a stop, and then up to the back up the tree, etc. It's the same tree structure as you see in the UI. So when a test starts, you get information about the test that is about to be run, or the test suite that is about to be run. When the test finished, you get the same, but also wrapped inside a test result that gives you result about how the test run went. As I mentioned earlier, the Unity test framework is able to run tests both in play mode in the editor, but also on devices. But we also added a customization point for running on devices. This is the modify options for for when building the player. We call this right before we're about to build the player, and you are able to modify these build player options as you like to change different settings for running, but also specify the build locations. So let's, enough about the theory, let's put it into practice.
Thanks, Christian. So yeah, you can look at the API. It's pretty straightforward. There's not a lot of things you have to learn there. But what I want to do now is walk you through some of the ways you could apply that API to kind of sketch out some situations. So the first one, a common thing that people are looking for, is what we call splitting build and run. So this is this ability to say, okay, I've got my tests, I want to run them on device, but the device is not attached to my local machine. The device is in the cloud. The device is 30 devices in the cloud, or something like that. So we've now made it possible with this new interface to split that process up. So what does that really look like if you want to implement that? First things first, you're going to customize the test player build process itself using the interface that Christian just described. You're going to disable the auto run so that once we've built the player, it doesn't then try to launch it and run the tests. And you're going to save it to a known location rather than into the system temp folder somewhere where we would put the tests by default. And secondly, you're going to add into the player side, you're going to add custom result reporting using the callback interface to capture all the results and save them out to an XML file or whatever other format makes sense for the situation in which you're working. So let's look at the code for this a little bit. First things first, these new interfaces, they are applied to your project using these assembly level attributes. So we have this assembly attribute, test player build modifier, with the type of the thing you want to apply. And this is so that you can have these things built up as functionality in libraries, just bring them into the project, and then just attach them in with just one line of code. So setup play mode test player is a simple class that implements this new interface. And we have the one method in there, modify options. It's going to receive the options that are being used to build the player, and it will return the options it wants to use. So it will modify and return. So the first thing we do is we're going to change the flags. So we're going to disable the auto-run player flag. And also we're going to disable connect to host, which is the flag that causes the player to search for an editor to send results back to. We're just going to say, skip doing that. There's no point. Like, the editor isn't going to be there. You're running in the cloud somewhere. It's fine. Second thing we're going to do is change the location we're building to. So in this case, I'm building up a path somewhere in the test players folder relative to my project root. And we're going to say that's the location we want to build to. So we know that once we've clicked the Run in Player button in the TestRunner UI, that's where we'll find the player that we can deploy to other machines. And then we'll just return our modified player options. So that's all it takes on the build side. Like, that's just going to kind of sever the link between building and running on the editor side. The second step is then implementing result reporting in the runtime. So again, we have an assembly level attribute saying we want to attach some callbacks to this test run. And we're going to have this class called results serializer that's going to do that for us. So results serializer, again, it's a simple class that implements this iTestRun callback interface. We have the callbacks for run started, test started, and test finished. In this case, they don't do anything. We have to have them in order to compile the interface. But we don't really need to do anything when a test is beginning or when individual tests are finishing. We're just interested in doing something at the end of the entire run where we're going to be given a result tree that captures everything that was done. So run finished is where we put interesting things. We construct a path where we're going to save the results to. In this case, we're going to save it in the persistent data path, and we're going to call it testresults.xml. Then we use an XML writer and NUnit's built-in XML conversion functions to save the entire result tree to that XML file with just a couple of lines of code. We write something into the log just to say, yes, we saved the results, and this is where, in practice, we've found that this just makes it a little easier to then track down, like, where exactly did that file go on device? And lastly, we're going to then quit the player, and we're going to change the exit code according to whether all the tests passed or not, which just makes it a little bit easier to set this up in some kind of automated situation. So that's splitting, build, and run. Next, let's take a look at launching specific tests from a menu item. Now let's do another quick show of hands. If your project contains a menu item that is called something like validate stuff or check things, raise your hand. Okay, yeah, there's a few. Okay, good. So those, like, I see this in quite a lot of projects, actually. people have written some kind of some sort of quick validation stuff. It checks a bunch of things. It checks bits of setup in a level or something like that, and they do all this. They kind of console.log things to get just messages out there. What if you could take that and you could turn that into a test suite so that you get a nice kind of individual green check mark, red cross, you get the details pane and so on. You have like a place that's in the editor that you go for that rather than just being lost in the flow of messages in the console. Well, with this technique, you can do that. So what does it look like? Firstly, you have a method that's wired up to a menu item, exactly the same way as you would do with any other editor extension menu item. So using the menu item attribute, using the generic menu class, however else makes sense for how you want to integrate it. That method is then going to create a scriptable object, callback object. Now, we use scriptable object in this case, rather than just a regular class, so that your tests can do things like causing a domain reload, and your callbacks can then survive across that. So inside the scriptable object, when it's enabled, we register for callbacks, and when it's disabled, we unregister. Then we're going to set up filters. I mean, frequently, when you're going to launch the test run menu item, you don't want to run all the tests. You want to run a specific category or a specific group. With the filters, you then execute the test run. And this can then run asynchronously. This will run over the course of several frames, allowing you to have Unity test, Unity setup, Unity teardown that tick the engine loop during the test. And then when it's finished and you get the on-run finished callback, you can display a message, open the results window, whatever else makes sense for the workflow that you want. So what does this look like? So we have our scriptable object class that implements the callbacks. We have a simple static function with a menu item attribute on it that is going to make an instance of the scriptable object and then start the test run on it. Starting the test run itself, there's a couple of little things in here. Firstly, an important trick, we set the hide flags on the scriptable object. We set it to hide and don't save, which will ensure that the object is never persisted or never becomes part of your project, but also is not going to be picked up by the garbage collector, is going to be kept alive across domain reloads and things like that. And then we're creating an instance of the TestRunner API, and then we're executing it with the particular filters. So in this case, we're going to run all tests that have the category useful tests. Then we have the implementation of onEnable and onDisable, just registering and unregistering. I've left out the implementations of run started, and test finished because, like the previous case, we don't really need to do anything with those right now. If you wanted to say, as soon as one test fails, then abort the whole run maybe, that could be a place to do that. But lastly, run finished. We have the result. We do something in there. I've elided that with a ... And then finally, once we've finished kind of dealing with the results, processing them however we wanted to, we destroy the scriptable object to kind of finish and shut down the run. So that's what it looks like to run them from a menu item. Next, let's take a look at integrating the tests into the build process. Now, this is a little tricky because the build process requires that the tests, that it requires that anything you do just be kind of run from a callback, and there's no opportunity to pump the engine update loop. So this limits a little bit what you can do, but there's still a lot of interesting potential here. Firstly, if you're going to do anything before the build, you implement it using the preprocess build interface, same way as you might implement any other kind of build preprocessing. You register a callback to get the results, as usual. You use the TestRunner API to run specific edit mode tests, because you can't go into play mode in the middle of a build. And yes, so filtering by category is a very good idea at that point. You want to pick the specific test, like your pre-build validation test category or something like that. And you run these synchronously. Now, funny story about this. The test framework did not have this feature to run tests synchronously about 2 weeks ago. And I started putting together this demo, and I was like, I really want to show people how to run tests during the build. Christian, it doesn't seem to have the ability to do that. Can we fix that? Yes. And we managed to turn that around. I think it took about half a day to implement and write the tests, and then another day to just do a release of the package. So,
yeah, Richard, I believe that you wrote the last lines of code for it while in the airplane.
Exactly. Just as the fasten seatbelt sign went on for landing in Copenhagen, I committed the last fix for the test. and then we released it the next day. So this is the power of it being in a package now. Like, you need something, we can design it, we can get it in there, we can release it, like 24-hour turnaround. It's very powerful. So lastly, once the run is finished, you check what the results were, and if something failed, you throw a build failed exception, which will cause the build process to abort. So let's break this down a little bit. Firstly, we have this result collector, which again is just implementing the callbacks. And the result collector is just going to capture the result at the end of the run and hold on to it for us, so that we can then query it back afterwards. So we have a property that's going to store the result. We have our empty run started, test finished. And we have run finished, which just saves the result into the property. So we can make an instance of this, hand it to the TestRunner API, it will catch the results for us, and then once we know the run is finished, then we can just retrieve them from that. So what does the post-processor look like, or the preprocessor even? So we have run validation tests before build. It's an iPreprocess build with report. And in the on the onPreprocess build callback, we're going to make a result collector. We're going to create the TestRunner API and register the result collector to receive the callbacks. And then we're going to start executing. And this time, we're going to say run synchronously true. Setting run synchronously to true means that by the time execute returns, we're guaranteed that all the tests have completed running and all the callbacks have been fired. And then again, we're going to apply a filter. We'll say everything in the pre-build validation tests category. And we'll just say edit mode tests, please. I think that's actually unnecessary right now. And so because we know that by the time execute is finished, everything is completed and the callbacks are fired, at this point we can just directly access the results that we stored in the result collector. We just say if anything failed, then throw a build failed exception. So that's it. That's all it takes now to integrate some tests into the beginning of the build process. And I think now it's time for us to switch to the live demo.
Yes.
Good.
Great.
Success. Right. So we've made this little demo based on the 2D GameKit sample. So I'm sure many of you will have seen this sample before, but it's a simple 2D platformer, and you can like transition between levels, go back and forth, things like that. So let's take a look at what it might be like to add some tests to this. So right now, there's nothing, no tests at all. So let's add a few tests. In classic Blue Peter fashion, here's some I made earlier. Tick, 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 tick. Wait for it to compile. And boom. Right, and we have some play mode tests. So we can run all of these in the editor. Run all. So these are just simple tests that when I simulate pressing jump, the character jumps to at least 3 meters, and when I press left, the character moves left, and when I press right, the character moves right. In practice, you probably wouldn't write tests like this, because if pressing right means the character doesn't move right, you're going to discover that pretty quickly. But still, we have some simple tests there. So I can run this in the editor. Now if I try running them in the player, so I can press that button, and it should start the build process. Yeah, spinning breach fall, and build. Building, building, building. Compiling shaders. Boom, 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 boom. There we go, and it launches, and oh good grief, that is not what we expected to see at all. So what happened? Well, the problem is that our play mode tests are using a specific test scene. And because it's a test scene, it's not in the scene list in the build settings. So when we're building a test player, we'd like to make sure that scene is included. Now, there was a way to do this before using the iPrebuild setup interface. But that would mean having to modify the global scenes list and making sure as well that you undid that modification afterwards. With the new interfaces, you're able to modify the player on the fly during the build process in order to do things like including scenes that were not otherwise there. So we step forward one step. And if I look in here into the code. I now have a very, very simple modifier in here. I'll make that bigger. Okay. Yeah, very, very simple modifier in here. It's just saying, if the test scene for the character test is not in the scene list, then append it. And that's it. So this is going to allow you to integrate test scenes and other test assets into the build while building a test player without it affecting the project in any kind of global way. Okay? And now we will see if I do run all in player. Wait for it to build again. Tick, 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 tick. And there we go. And now it works. So very simple. Oh, and one flaky test, but that's just life. Okay. So let's move on to something a little bit more interesting than just adding a scene to the build. How about we do that split build and run thing? We step forward one more. So now I've got in the project exactly what we talked about before. So I have this test player build modifier. Which, exactly as we described earlier, is modifying the options. So it's turning off auto run player, and it's turning off connect to host. It's setting the path to somewhere known. It's setting a flag for now, just for us to know whether or not a test player has been built in this session. And then it's returning the modified options. The flag, by the way, is used for the second class, which allows us to say, if you launched the editor using the -run tests command line parameter, and then we built a test player, then please exit after it's finished. Because by default, using the run test parameter, the editor will wait to receive test results, and we don't want it to do that because we know it won't receive them. So we just use that to kind of control this second thing and make sure that it exits in the right scenario. So now, with that code in place, I can come back here and press run all in player. And again, we're going to build for a little bit. I think this is the last build. Okay. Okay, and you see this time it hasn't launched any tests. If I look in the Finder, I now have, in my test players folder, here's my player with tests. It was not there before. And now I can launch this, and the tests are there, as before. And they've saved out the test results XML file, just as described with the results serializer. So that's how that works. And I could have built like a Windows player and given that to Christian. He could have run that on his laptop. I could have built iOS. I could have deployed it to wherever. So yeah.
Yeah, the strength of this is that if you have a limited amount of devices, then you can build your player on cheap machines and then ship it to the machine that has the device.
Mm. Yeah, this is true. I mean, one of the main uses that we have for this internally at Unity is for our graphics tests, being able to build the player that's going to contain all of the shaders and graphics scenarios that we want to test without tying up a machine that has a GPU, as those are quite expensive. So let's look at something else now. So as I said before, you probably wouldn't create these tests that are just kind of making sure that when you press left, the character goes left. It's not super useful. I mean, in a larger case, in a larger project, like maybe if there's different movement modes, it's worth having that. But here's a case I think is going to be a bit more compelling for a lot of you. What I call content validation. I think what everyone else calls content validation as well. So I have a couple of tests that I've added here for validating that the enemy prefabs in the project are set up with appropriate settings, and that the scenes all have certain properties. And there's a trick I've used here, one of my favorite tricks. I love parametric tests. I love tests that are, you write it once and it applies to many different scenarios. And this is using things like test case source, test case values, and so on in NUnit. But I like to kick it up one level further and use parametric fixtures. And this lets you create a whole little suite of tests in a class and then instantiate the whole set of them for different values. So here's my enemy validation tests. So I have the class of them here. I have two tests. One checks that the prefab is on the enemy layer in the project, and another is checking that if the enemy has a projectile prefab set, then it should also have like a shooting position that the projectile is going to be spawned from. It either has to have both or neither. It's not allowed to have one and not the other. So two pretty simple tests. And then the constructor for the class is receiving the prefab it's going to test on. Okay? We then have this test fixture source that is telling it where to get those different game object values from. So the enemy prefabs provider, just here, is a very simple IEnumerable of game object that is going to find everything that is a prefab in the enemies folder. It's going to load each one of them, and as long as it has an enemy behavior component on it, it's going to return that game object. So this is a really powerful way to just say, I want to run these tests on everything in this folder. And I can have a similar setup for the scene validation tests as well. So again, we have our class, we have a constructor that's going to take the path to the scene to test. We have a one-time setup that will load that scene in order to do the testing on it, if it's not already loaded. And then we just test some simple things. Is there a start position set in that scene? Does the start position overlap any platforms? Let's make sure that the designer hasn't embedded the player halfway on the floor. All of the transition points between scenes refer to other scenes that actually exist. All the moving platforms have at least 2 points on their path to move between, things like that. So, and then we have the provider, again, which is just looping through all of the scenes in the build settings and saying, like, as long as it's enabled and it has zone in the name, then return that scene as well. And so this means that we're able to come back in here and let's take the zone 1 tests. So I can run these. Okay, so it skipped the moving platforms test because there are no moving platforms in that scene. But then the other tests will pass, and that's cool. And this is the scene I have open right now. So I can actually grab the player character, and I can say, you know what, let's break this. Let's stick the player on the floor. Save that. And now run the test again, and now I have a failing test. Surprise, surprise. So that's pretty cool. That's pretty cool. And I can run all of the tests. I can say, okay, let's take all the scene validation tests, run selected, and it's going to go through each scene one by one. You can see the hierarchy changing as it loads each scene in turn. And all the scenes coming back green. Great. That's cool. But is this best workflow? Like, if you have your designers and they're working on the level setup and so on, do you want them to go into the TestRunner window? Or is there a smoother way? Like, is there a way that you would be able to integrate that would get them to run the tests a bit more proactively? Well, what we can try doing is we can integrate the tests for that particular scene into the context menu for when you look at a scene. So now I've got this little run validation tests option here. And this will automatically run the tests for, yep, there we go. All 3 validation tests passed, this scene's looking good. Sweet. And again, I can come in here, I can take the player, move them down a bit, run the validation tests again. Oh no, failed test. See the TestRunner output window for more details. And it opens up the TestRunner window automatically. So that's a pretty nice workflow, right? Like, I mean, if there's a lot of information that your test is going to produce on a failure, the designer can then go and look at the failing issue and read all the detailed information in the tab there. And as we move forward with the TestRunner and we expand the capabilities and make it pluggable and extensible, you can put some really rich results in there. Like, we'll be getting to that sometime in the next year, hopefully.
Yeah, that's the plan.
Yeah. So how did I do that? How did that work? Let's take a little look. So I have this run scene validation test from context menu. And this is using the run from menu item pattern that we talked about before. So it's a scriptable object that also implements the callbacks. And rather than using the menu item attribute, I'm using this scene hierarchy hooks add items to scene header context menu event. I'm registering that event using an initialize on load and a static constructor. And then at that point, I'm then explicitly adding the menu item to do what I needed to do. And I'm actually passing through the current scene, or like the scene that the user's clicked on, as a context object. One of the nice things about this is that I could maybe have several scenes open at the same time, and the context menu item would still only test the particular scene I clicked on. So in do run tests, we're then saying, OK, create the instance, start the test run. In start the test run, we're doing as we said before, setting the hide flags, and then starting an execution. When we enable and disable, we're registering and unregistering the callbacks. There's nothing to do in run started, test finished. And then in run finished, we look at the results and we decide, OK, if everything passed, then everything passed, great. If something failed, then we build up a little list of the names of the tests that failed to be able to report. And then we execute the TestRunner menu item in order to open the TestRunner window. And then finally, we clean up the object. That's a grand total of 108 lines of code for integrating that. So, not bad. So let's look at two more techniques. One is integrating the tests into the build process. So, we've got our nice enemy validation tests, making sure that things are set up correctly. Let's make sure that we don't even try making a build if the enemies are not working, because the build is going to be so broken, like, what's even the point? So, we've now got our run enemy validation test before build. And again, this is just the pattern as described earlier. I preprocess build with report. In on preprocess build, we're then making our result collector. I have a tag here just to change the messaging slightly. We make an instance. We execute filtering on the enemy validation tests. And then if something fails, we report the results into the console, and we throw a build failed exception to halt the build. If they passed, we just log a regular message, just so we know the test did actually run. Okay? Silence is not necessarily something you always want to trust. So if I grab one of the enemies in here, so I have my spitter prefab, maybe. And we can see spitter prefab. I don't know whether you can see there, but yeah. So I can run the test right now, and that's fine. Yeah, it's on the enemy layer. It's got things set up correctly. And if I stick it on a different layer, put it on the level layer, this object only, and now run, that's fine. Cool, OK, the test is failing. So this should now mean that when I try making a build, oh, that was very quick. Sudden failure. I dig in there, build failed exception, enemy validation tests, spitter prefab, does not have, yeah, it is on enemy layer, failed. Okay, so I was able to block the build with a very, very quick smoke test. And I put them back. Separate only, build, save. Okay, and this time the build is gonna succeed. So that's pretty cool. Like, you would have maybe a category of pre-built validation tests. You want to keep them small, fast to run. And frequently, you wouldn't want to, like, often it's valuable to be able to create a build that is broken in various ways. But if there's certain things where you won't even be able to get past the initial loading screen, what's the point, So that's pretty cool. But let's look at a combination of techniques now. Let's look at integrating with the build and also running the scene validation tests. So this one's a bit funky. Rather than running the validation tests at the start of the build, what we do in this case is we run it during the build. We use the iProcess scene with report, which is a callback that is called for every scene during the build process. So we don't run the tests if the scene's being loaded in play mode, because this callback is also called then as well. We make sure that we're only checking like the actual gameplay scenes. We don't want to run this test on our UI scene or the start menu or things like that. And then we do similar to what we were doing for the pre-build. So we have our result collector, and then we execute synchronously the scene validation tests for the specific scene that's being processed. And then again, if anything failed, we report the results, we throw an exception. If everything passed, then we just say, yep, everything's passed, everything's fine. And this is pretty neat. Like this allows us to, during the build process, just check a few things in the scene without spending time loading the scene. The scene's already there, the build process already opened it up for us. And we can just take advantage of that to check a few things. We have to be careful that our tests are not going to modify state. that their tests are not going to create things into the scene that would accidentally be left in the scene during the build process. But if all you want to do is check certain things like, are things on the right layer, is the player character overlapping the ground, things like that, that's entirely just reading information, and that's fine. So again, I can pick one of my scenes. I can pick scene 1. Oh, player's still on the floor. Perfect. Or not perfect, depending how you look at it. And now I can do my build. I'll just clear the console first. Build settings, build. Place. Okay. At the moment, this technique does slow down the build process a bit. There's a bit of unnecessary work being done, but we're going to take a look at maybe trying to streamline that to get the speeds back up to where they need to be. And you can see already, there we go, it fails. And the first error message there, scene validation tests, start position does not overlap any platforms failed. Okay, so I was able to block the build in there. And again, I can just go and fix it. Bump, bump, save, and build, and save. I should point out, by the way, when these tests are failing, I could also go to the TestRunner window and see also the state there and read the detail there as well. We're not kind of dynamically creating a special set of tests. The tests exist and are fully understood by the TestRunner window. We're just selectively running a group of them at a particular time. Okay. Yeah, so this time it has made it further, and there we go. This time the build succeeded, made it all the way through to the end. So, I think that's it for the demo. So we just have a couple of things to finish up with. Come on. There we go. So, if you'd like to learn more about the test framework itself, Christian's written some lovely documentation, which is up on, you can find it at tinyl.com/unitytestframeworkdocs. If you want to talk to us about the test framework or talk to each other about how you're integrating it or just get help with testing or CI or automation or other tasks related to kind of automated handling of Unity, then we have a new forum for that set up, which is tinyl.com/unitytestforum. We're going to try and spend some time at the Ask the Experts bar over the rest of today. So you can come and ask us questions there, show us your projects, show us your hardest problems, and we will solve them. And we have a little bit of time for Q&A. So there's microphones at the back of this block and that block of seats. If anybody wants to grab the mic, ask us some questions while you have the developer of the framework himself here and me, who talks a lot, then take the opportunity, or you can come and find us afterwards, or you can come find us at the expert bar. Any questions, anybody? Yep.
Hi. Do you have any plans to have input testing? So, yeah.
Input testing.
Yeah.
Yep.
So mocking of inputs?
Yes.
Yeah, there's something that's on our radar that we are trying out the different approaches for.
Okay.
Yep.
Thank you.
Cool. I was wondering for the separating out building and playing of tests, if, for example, you want to run tests on a device like iOS, what mechanism do you use to launch and so you've built the IPA, for example, then what do you use to actually deploy it to the device, run the tests, and get the results back out?
Right. So, yeah, I mean, so it's much along the lines of deploying any application to that platform, right? I mean, and it's going to depend on the platform. So, on a console platform, you would use the host-specific tools to say, okay, please copy this over. I'm pretty sure that with iOS, there is a way to sideload an IPA on there, through Xcode or through iTunes. I can't remember the details, unfortunately, but there is some way to copy it on there. If you don't find it, that's a really good question for our forum, and then we can kind of dig into that and make sure there's a way to kind of deploy that to device for you.
Yes.
Okay.
Yeah, we have tools for that kind of thing, but they all have their own pains. I was just wondering if there was a way you recommend it.
I don't think we have any magic solution that solves that one right now. But if we should make one, then let us know.
Cheers.
Okay.
Is there a min Unity version for this, other than ones that support the package manager, obviously?
Minimum Unity version.
So that is 2019.2.
Okay. I mean, we do have versions of the test framework with fewer features for these things, obviously, in older versions as well, but I think these new APIs require 2019.2.
Yeah, that's correct.
Yeah.
Thank you.
Anyone else? Any questions? Nope? OK. Right. Thanks very much then, everybody.
Thank you very much.